Hi, I'm Curt Frye. In this movie, I want to take a look at a knapsack problem from a different perspective. So rather than fitting as many packages or as much weight as possible into a container, I want to use the containers that we do use as efficiently as possible. The sample file that I'm using, called knapsack_efficiency, can be downloaded using the link that I provide in the video description below. In this worksheet, which does have a lot of information in it, but we'll simplify it down for this problem, I have 17 packages and the weight assigned to each of them. And weight is our limiting factor because the containers can only hold so much weight with their capacity. The container that each package is assigned to is here in column C from C4 to C20, and those are our changing cells, which I have marked in yellow. In columns E and F, I have two sets of weights. One is the original set that is currently in column B, and the other is another set that we can experiment with. To the right of that, in columns H and I have the 5 containers with their capacities. So I have 2 at 80 and 3 at 50 for a total of 310. Below that, I have 2 bits of information that we don't use for the solution, but could be included if we wanted to. One of them is unsent weight, and the other is the number of packages that have been assigned to each container. So that is the count. I already have the count formulas put in, so we don't have to worry about them. And then over on the right, I have a list of 5 containers. And to the right, I have calculated the load that is currently in each of the containers. And I do that using a SUMIF formula. So the first part of the SUMIF, and I will double click so we get a larger version of the formula, looks in the range C4 through C20. Those are here. Those are the changing cells. Then we look for the container number in K4, and if I press escape, that's the one here. And then we'll do the same thing for K4 through K8. Double click again, and we're looking for the load by adding up the weights that are in column B. So those are the weights here. And we find the total. We have the total here, and then we have the sum of all of those values. To the right, I have a new efficiency calculation, and what that will do is determine the amount of a particular container's capacity that is used. And there's one thing that I will do that is a little bit different. If we don't use a container at all, then we assign it an efficiency of 100%. And the reason we do that is because if we don't have to send a container, then we're saving money on shipping, and if we don't need to use it, it makes sense to do so. So I'll select cells M4 through M8, and I can enter the calculations into all of those cells at the same time. So I'll type equal. We'll use if, because remember we have 2 scenarios, if the container is empty, that is it has 0 weight in it or not. So if, left parentheses, logical test L4, which is the load, divided by I4, which is the capacity, equals 0. If it is, comma, value of true, we'll give it an efficiency of 1 or 100%, then a comma, and the value of false will just be the result of L4 divided by I4. Then a right parentheses, and to enter the formula into all the cells simultaneously, I will press Control Enter. So I currently have all the containers empty, so I have an efficiency of 1. And then I'm looking for average efficiency. So in cell M9, I will type an equal sign and have the average of values in M4 through M8. Right parentheses and enter, and there is my calculation. And just to make sure things are working properly, I'll go over to C4, type a 1, enter 2, 3, 4, and 5, and there we go. It looks like we have our calculations working correctly, and our container counts are up to 1, and the unsent weight is at 164. So we're doing okay, it looks like. Now we can build our solver model. So I will go to the Data tab of the ribbon and click Solver. The objective cell, and I'll drag over to the left for a moment, is cell M28, M9. Not sure where I got 28 from. And we want to maximize the efficiency, and we'll do that by changing the variable cells, which I mark in yellow when I develop a spreadsheet. So I have C4 through C20. and I will expand the dialog. And now we can add our constraints. So I will click Add and drag the Add Constraint dialog box to the bottom right so I can see all of the values in my worksheet. I need to have C4 through C20 be integer values, so I'll select C4 to C20. And then for the comparison operator, int for integer, then add. And each of those cells need to have the value from 1 to 5. So they need to be less than or equal to 5. Again, they are integers or whole numbers. Add. Same cells must be greater than or equal to 1. Then I'll click Add. I have enough capacity to send all of my weight, so I need to set I11 unsent weight to 0. So that will be I11, and I need that to be equal to 0. And add. And finally, I can't put more in a container than its capacity. So that means that L4 through L8 must be less than or equal to the capacity, which is I4 to I8. Those are all the constraints that I need. I'll click OK. I have an if statement, so I need to go from nonlinear to evolutionary. That means we're going to be having solver generate solutions and then find the best ones from the population and use those to improve by combining them. I also want to check to ensure that I have the bounding set correctly. So I've clicked Options, and then on the Evolutionary tab of the Options dialog box, I have Require Bounds on Variables checked. That's good. Make sure it is if it isn't in your copy of Excel. Click OK. And I think we are ready to solve. So I'll click the Solve button, and hopefully we will get a solution. It took about a minute to get a solution, but it appears that we do have one. So I will click OK. And the first thing I will do is ensure that the load is 238, unsent weight is 0, and that means that the weight is 238, so that looks good. And let's take a look. I have a 0 load and a maximum load, so those are efficiencies of 1. And other than that, I have 0.9, 0.86, and 0.94 for an average of 0.94, which is very efficient for my containers. And because we didn't need to use all of our capacity, we have 4 of them in use, and 1 of them can stay home, and we don't have to pay to move it. Now let's run another solution. I'll take the second set of weights, and here I have 276, and that's more than 310 minus 50, which is the minimum, so we will need to use all of our containers. So let's see what that looks like when we run it. So I'll select F4 through F20, Control C to copy, then I'll click cell B4, Control V to paste. There we go. The solution isn't good anymore, but what we can do is rerun the model and see what we come up with. So I'll go to Solver, click Solve, and be back when we get a solution. All right, it looks like we have a solution, so I'll click OK. And we have our container loads. 2 of them are at the max. 1 is very close. 1 has about 12% unused capacity, and the other is at 70%, roughly. So it appears that we have a pretty good solution, and our unsent weight is 0, so we are able to fit everything in. And an average efficiency of 0.91, even though we have one of our containers that's fairly low, is quite good performance. So if you want to create a model that uses a different type of criterion, in this case efficiency, this is how you would do it. I hope you enjoyed this movie. If you did, please like it and subscribe to my channel.